In this video, we're going to continue to talk about the unit circle. This is the third explanation. Let's go back to Desmos. Let's imagine that the unit circle does not exist. Let's imagine that right triangles are the only way that we can think about sine and cosine. Now, this is probably review for you, but what does the sine of 30 degrees actually mean? What does the sine of 30 degrees actually mean? Well, let's make a 30-degree angle. Okay, so this here is 30 degrees. Let's imagine that this is in a right triangle. This would be the opposite side, right? This would be the hypotenuse. If we do opposite divided by hypotenuse, we would get the sine of 30 degrees. Okay, what does the sine of 120 degrees mean? The sine of 120 degrees. Well, that's interesting because we would need to make a 120-degree angle. So here we go. This right here is 120 degrees. And then that would have to be in a right triangle. How do we even do that? Well, maybe we could do this. However, this is not a right triangle. Maybe some of you are thinking about this, and now this is a right triangle, but the triangle does not have the 120-degree angle. The 120-degree angle is on the outside of the triangle. I think we're trying to make a triangle that's impossible. Now, some of you that remember geometry very, very well are probably yelling at the screen. Of course, this triangle is impossible. You can't have a triangle that has a right angle and a 120-degree angle because that's too many degrees, right? All the angles in a triangle have to add up to 180 degrees. So let's think about this triangle we want to make. How many degrees do we have? Well, we have a 90-degree angle because, it's a right triangle. And then we want this 120-degree angle to be in there. Okay, so these two angles here, how much do these measure in total? 210 degrees. That's more than 180 degrees. We've gone over. We have exceeded the number of degrees that we are allowed in a triangle. So yeah, this triangle is definitely impossible to create. And if it's impossible to create a right triangle with an angle of 120 degrees, then what would the sine of 120 degrees even mean? Sine has to do with right triangles, yeah? Yeah, but how can you do the sine of an angle that you can't even have in a right triangle? How can you do the sine of an angle that is impossible to fit into a right triangle? But what if we really cared about this? What if we really wanted to do the sine of 120 degrees? And we were like, is it possible to create new math that would allow us to do the sine of 120 degrees? Is it possible that we can extend the possibilities of sine so that we can do sine of big angles, like 120 degrees? Well, mathematicians sat down and thought about it and created a new way, and that is the unit circle. But why did they decide to create the unit circle? Like, what's so special about the unit circle? Well, let's talk about that now. Let's make a small angle again, and let's see how right triangles relate to the unit circle. So this angle here is, I don't really care what the number is. Let's just call it A. But let's try to draw a right triangle in here. What would the sine of A be? Well, It would be opposite over hypotenuse. But what is opposite? What is hypotenuse? Is there another way of thinking about these sides of the triangle? Well, the opposite side is the same thing as the y coordinate of this point. Because think about it, the y coordinate of this point is how high the point is. And how high is the point? Well, whatever this distance is, the opposite side, right? So they're the same thing. So opposite over hypotenuse is the y coordinate over the hypotenuse. But what's the hypotenuse? Is there another way of thinking about the hypotenuse? Well, the hypotenuse of the triangle is this line here. That looks like the radius of the unit circle. Do you remember the definition of the unit circle? Do you remember how long the radius of the unit circle is? It's 1. The radius of the unit circle is 1. So this is y over 1, which simplifies to y. So sine is literally just y. Sine is the y coordinate of this point. What about cosine? What would the cosine of this angle be? Well, cosine is adjacent over hypotenuse, and this is the adjacent side. We just said that the hypotenuse is 1, so this is adjacent over 1. What's adjacent, though? Is there a way we can think about the adjacent side of this triangle? Well, yeah, the adjacent side is basically just the x-coordinate of this point. Because think about it, the x-coordinate of the point is like this distance here. It's the horizontal distance from the center of the graph to the point. But wait, that's the same as this distance. It's the same as the length of this adjacent side. So the adjacent side is the x-coordinate of the point. X over 1 simplifies to x. So the cosine of the angle is the x-coordinate of the point. Sine matches the y-coordinate. Cosine matches the x-coordinate. So if we're creating new math, if we're creating a new definition for sine, then choosing the unit circle would make a lot of sense, right? Because there's this connection between right triangles and the unit circle. So yeah, the unit circle is a good choice for a new definition of sine. And the benefit of the unit circle, the advantage of the unit circle, is we can talk about really large angles. We can talk about angles that we would never find in a right triangle. So we can go to 120 degrees, and we can find the sine and cosine of this now, thanks to our new definition. So that hopefully you can see that the cosine of this angle is going to be the x coordinate, right? So it'll be negative 0.5. And the sine of this angle is going to be the y coordinate. So it'll be 0.866. We could even do the sine and cosine of much larger angles. Like what even is this? I don't know, 228 degrees. Okay, there you go. So cosine is the x coordinate. So cosine would be negative 0.669. Sine is the y coordinate. So sine would be negative 0.743. So the point is, mathematicians created new math to create new possibilities for sine and cosine. Thanks for watching.